For the 2022 fall semester of DFT 170 Engineering Graphics, taught by Dr. Hans Chapman at Cape Fear Community College, this is the SolidWorks modeling of an amusement park ride presented by Kate Golden and Nathan Santi. Here is the context of our model. This model was heavily inspired by the amusement park ride called Da Vinci's Cradle at Busch Gardens in Williamsburg, Virginia. It is shown in Figure 2. Da Vinci's Cradle features a cart that swings back and forth, like a pendulum or a Newton's cradle. Our model follows the same path of motion, but some creative liberties were taken in the design of our ride. The hand-drawn sketches in Figure 1 show the foundation of our model, including the basic framework and dimensions. One of the main components of the model is the base. Our base mimics a bridge truss. The members of the truss can be seen in Figure 4, where they form triangular supports. The platform, technically called the deck, of the base is shown in Figure 5. Simply, it's an extruded rectangle. And to form the assembly shown in Figure 3, the parts in Figures 4 and 5 were mated. The vertical part of the ride's frame is what we refer to as the stands. They act as a pillar situated on top of the truss portion of the base. They are extremely important for connecting the part of the model that riders sit in with the base. The supports shown in Figure 7 act as a reinforcement to the stands. They were made by extruded cuts into a rectangular prism and feature triangular brackets and two wheels on the side for decorative purposes. The cart is composed of a platform and seats. The platform of the cart was created using the Boss Extrude and Fillet features. The seats also use Boss Extrude, but the shell feature was most useful in creating the seat. The assembly of the two components is shown in Figure 8. The cart attachments connect the stands of the ride to the cart. An extruded cylindrical shape at the top of Figure 11 allows for this to happen. The hole at the bottom of the part connects to the cart via the mate tool. The assembly of the ride is divided into two main components on this slide. Because of technical difficulties and time constraints, these two components remain separate. The drawing documents for each components are shown in Figures 14 and 15. The top, right, front, and isometric views give us a better perspective of the model through every principal view being visible simultaneously. This was most helpful in viewing the front supports. The outcome of the cart simulation was far more successful than the base simulation. A lot of deformities arose at 5,000 newtons. The platform of the cart is warped and the seats are unstable. From this perspective, the entirety of the model was blue under force. This is an animation clip of the rotational aspect of our project. The way the ride functions is through the cart swaying back and forth in between the stands. The cart attachments are mated to the cart itself, but still have the capability to rotate 360 degrees. But when the entire cart assembly is fixed to the stand, the cart will also move 360 degrees, but it stays parallel to the base, meaning that it has a little bit less range of motion. Here are some concluding remarks. This project was definitely a learning experience, and I think some of the lessons included modeling as a process of trial and error. Brainstorming and sketching prior to starting the SolidWorks model helped tremendously, and small setbacks don't inhibit your ability to create a successful project. Some things that could have been improved were coordination, dimensioning, and simulation and animation.